Hi, my best beloved chemistry students. It's good to know that you're watching your videos like you're supposed to, like my wonderful good kids always do. Let's move on. We're talking about reactions, and I want to move into combination synthesis. They've got a variety of names: combination synthesis or addition. I tend to call them, and I likely will if we're talking about them in class, I would typically call them a synthesis just because that's what I'm used to, and decomposition, which they're pretty much the opposite of one another. You're not going to have to memorize a bunch of rules. There's going to be enough information, some data given, or enough information in the problem to give you an indication of what forms. If it's elements going into a compound or a compound going into an element, you should be able to predict those because that's simply formula writing. And you know how to write formulas by now. Some of the more complicated will give you information. Now, these are typically not in an aqueous solution, which means it is not appropriate to use net ionics to represent it. To be an ion means it has to be able to dissociate, which requires the presence of water. Now, decomposition, not always, but decomposition, my Mimeo is going all over the place. I'm sorry about that. That's what you feel like doing when you don't understand it, right? Decomposition is typically going to need an input of energy. Not always, but typically either heat or electrolyzed in order to get it to go. Maybe a catalyst added. So let's take a look at examples. Element plus element going into a compound will always be a redox, reaction. Okay, again, my Mimeo is hopping. I don't know why it does that, but we're going to move on. In this case, for the synthesis, I have a stream of hot nitrogen. So nitrogen gas, N2 gas, is blown over a piece of sodium metal. All right. Now, pure nitrogen, 0 oxidation. Pure sodium, 0. Now, when sodium goes into an ionic compound, it's -1. When nitrogen is in an ionic compound, its oxidation number is -3. In ionic compounds, you make nonmetals the most negative they can be. So I would get Na3N solid. Now, decomposition means to take that same substance, provide some sort of energy like heat or an electrolysis, and I would get my sodiums back, 3Na plus N2. Again, it's a redox, +1 -3, 0 and 0. Sodium, in this case, gained electrons. It was reduced. Nitrogen lost. It's less negative. It lost electrons. So it was oxidized. Let's go on to a couple more examples here. These next two are compound plus compound. These are typically not going to be redox, but I would always assign oxidation numbers just to be sure if I was asked that question. So as a synthesis, if I had calcium oxide, ionic compounds are solids exposed to a stream of, so plus carbon dioxide. Most of these you can pop together. And there you go. 1 calcium, 1 carbon, 3 oxygens. This is chalk. Calcium carbonate is chalk, or it's what's found in shells and that type of thing. Decomposition is going to be the same thing. Now, how would you know what would form in a decomposition? Well, you'd see this white solid. So we know it's not pure calcium because it's white. So we'd see calcium oxide, and you'd collect, you'd collect a gas, not CO3, CO2, and a lit splint would extinguish. It would go out. That's how we know it's CO2. A lit splint pops in hydrogen, a glowing splint relights in oxygen because oxygen can facilitate combustion. Now, carbon dioxide bubbled through water. That's what we have when pop is made, right? That's how you get the carbonation. And it forms H2CO3, carbonic acid. Now, when you open up your pop, what happens? It fizzes, gas forms. And that's because the H2CO3 decomposes to form H2O, which just stays in the soda, and CO2, which is released as a gas. Right? Now, both of these can happen actually at the same time. So sometimes you'll see it written with just one of them, and we would use a double arrow to show that it can occur in both directions. We'll talk quite a bit more about that next few units from now. Okay, so that gives you synthesis and decomposition. We'll be doing some experiments with this as well. And hopefully you will enjoy those. You've already done some already in pre-AP. We'll be doing some more. So, till class, this is signing off.